pleasure, such an honor to connect with you all. You have a lifetime opportunity that is being given to you by Susti and Vairak through this Sitare BIS program, innovation ignition. I think these are the key words because each one of us has that gene of inventing, innovating, but it has to be triggered, so as to say. There has to be an expression that has to be given. Don't forget that SRISTI is Society for Research and Innovation for Sustainable Technologies and Institutions. And Professor Anil Gupta, you are again, I consider him as not only my innovation guru, but for us in India, he is the innovation guru. They have partnered with BIRAC, which is Biotechnology Industry Research Assistance Council. Again, they are doing a fantastic job of promoting both innovation and entrepreneurship here. And this Sitare program, which is Students Innovation for advancing research explorations. I think that's a great opportunity. So first, I want to congratulate you and tell you how lucky you are. The second part that I want to emphasize is that this COVID pandemic has shown to us the importance of science. So you can see how privileged you are to be in science, doing science, scientific research. I always say science must solve, technology must transform, and innovation must impact. And you have an opportunity to do that. And you have witnessed, for example, what our science has been able to do. I mean, when the pandemic started, we didn't have any diagnostic kits, we did not have any personal protection equipment, we didn't have any ventilators, we were importing everything. We knew nothing about the virus, we didn't have vaccines. And you can see within such a short time, Indian scientists have risen to the occasion to an extent that people are now saying that 2020 is the year of Indian science and Indian scientists. So that's something very, very sort of special I want to emphasize. Professor Anil Gupta has asked me to look at my, I would say, book of my own life and narrate to you and relate to you, how I became a scientist, what was the experience that I had in doing science, the exhilaration of science, as well as sometimes exasperation because you fail, etc., etc. So rather than looking at the books that you see and what I read from that, I'll tell you from the book of my own life as to what I have experienced. So how did I get into science? I think that must be the first guess, because most parents, they start debating where should one go for arts, for commerce, for law, for this, that, and the other. How does one choose science? But I must say I was lucky to get into science or have a desire to enter science that was triggered by my teacher. So I will start with that story and tell you from there. For that, you need to understand a bit of my background. I was born in a very poor family. My name is Mashelkar. I was born in a village called Mashel in Goa. My father passed away, unfortunately, when I was 6. I was the only son. And my mother was illiterate and she brought me to Mumbai. And she was doing actually menial jobs to, and we got going somehow or the other. 2 meals a day was a challenge. I studied under street lights. I walked barefoot until I was 12 and so could study only because of scholarships and so on and so forth. Now, there is an interesting part of it that I studied, by the way, in a municipal school in local language, in Marathi, and it didn't make any difference. That also I must tell you. And in the 7th standard, I remember standing first with some 88% marks or something like that. And I was going to leave education. I was going to, because my mother, she was working hard to bring me up and I thought I should take up a job and so on, or do a night school. That means I study at night and during the day I do some work. And to get into secondary school, we got 21 rupees. We did not have, and it took 21 days. to get that. And by that time, all the great admissions in great schools were over. And I went to a poor school, Union High School. But that school had rich teachers, and one of them was Principal Bhave, who changed my life. What he used to do was to actually, he didn't believe in chalk and talk. He would take us and show us, for example, soap making. All of you must have studied soap making, and you know all the equations, and you will get 12 out of 10. Perfect. But how many of you have seen a soap factory? He would take us to a soap factory, Hindustan Levers, near Sivri. I remember that was my first travel in tram, and that 5 paisa ticket also I could not buy. He was himself was poor, but he bought it and showed to us how soap is actually made. He took us to a factory called Wimco, who were making matchboxes in Ambernath. That was my first train journey, and he paid for my ticket. So he wanted us to see and learn. There is what is called by learning by doing, but learning by observing, learning by seeing. And that education I got at a very early age. Then one experiment that changed my life was that he took us out one day into sun, and he was showing us how to find the focal length of a convex lens. And he had this convex lens here, he had the piece of paper, he moved it up and down. And when the brightest spot came, he said, this is the focal length. And then he held it for some time. And the paper burned. And then he turned to me for some reason and he said, Mashelkar, like this, if you focus, you can achieve anything. All right. That did two things to me. One was the magic. I said, my God, science is so powerful. I must become a scientist. The second was philosophy of life. Focus and you can achieve anything. Don't divert your energy. But as I went forward, I started saying, today we talk about renewable energy. We talk about solar energy. I started thinking about solar energy then. Because I said, why, in order to burn a newspaper, I should use a matchstick? That's a waste. Why can't I just use that lens and just focus it on it and the paper will burn? Can you just imagine so many years ago, I started thinking about that. And there was such a big impact on me. And that is how I actually entered science. The other part of it was that finally I got into chemical engineering, became sort of a chemical engineer. And then I was always first in the class, and I had, I think, 4 or 5 fellowships to go to US. But I have always done things rather differently, by the way. In a sense, it was conventional to go to US and do all the top students used to, we call it brain drain. I mean, people go and don't come back, etc. But I had met Professor M.M. Sharma, by the way. He's a great individual, by the way. He's himself, decorated by the nation in many different ways, but an extraordinary, inspiring human being. And he was my lecturer. He was teaching us. He would put his 2 hands in his pockets and come and brilliant 45-minute lecture, teacher. So I said, where can I get a better guru? So I said, forget about those fellowships. I will work with him. And we did work on what is called as mass transfer with chemical sort of reaction. It's a topic very easy to understand. All of you are science students. So if you take a sodium hydroxide solution and bubble carbon dioxide through it, sodium carbonate will be formed, right? But for that, the carbon dioxide from the gaseous phase has to diffuse into the liquid phase, and there has to be a reaction. So there is a diffusion and a reaction. How does that take place in bubble column? That was the kind of study. And he was, of course, a great PhD, but there was another lesson that I learned, which I want to give you. In each of the stories I'm going to tell you, there is a lesson, by the way, that you have to take home. And the lesson was, we were so poor at that time in terms of facilities. I'm talking about India, not now. I'm talking about India of the 60s. That I remember the Perspex column that we needed. I remember he had a friend called Purohit. I went and borrowed it from him. We needed a solvent, sulfolane, all right, to do reaction. I remember going to Tata Nosil factory with a tin and getting it sort of all the way. So it was kind of begging and borrowing by which we did the research. But As Professor Sharma always used to say, it is not the power of the budget, it's the power of idea that matters. And with that limited resource, the kind of research we could do, I remember there was a tripartite conference of chemical engineers of UK, of Canada, and US, and very select people were invited to read a paper. And I remember our paper got accepted there, and it was a kind of a breakthrough paper. So it has nothing to do with money, by the way. It is all up here. It's the power of ideas. Your ability to sort of do that is extremely important. The third story I will tell you is again because Professor Gupta, Anil Gupta has asked me to sort of tell you about my life, how life changes, you know. So what happened was that I had done my PhD thesis on bubble column, and Professor R. Kumar is a great mind, by the way, great mind, one of the greatest mind that I've seen. He was doing my PhD, he was my PhD examiner. So, you know, in those days, it is not like what you have now. You know, we used to type, and there was carbon paper, and then you type on that, and then there is a copy. There is another carbon paper, there is a copy, and then you take that out and sort of bind, etc. Not like today, you know, there's a question of copy just doesn't arise. You just email to thousand of your friends. You don't have to take 1,000 copies. So that bound thesis was there, and he was turning pages, and then he asked me. He said, Mashelkar, you have worked on bubble columns. So describe a bubble and the liquid around it. And how did the bubble move up? And what is the stress, the shear stress, the distribution, circulation? I've never heard about it. You know, because this was all fundamental fluid dynamics. And I was just bubbling and for finding out some transport coefficients. I was completely empirical. And can you believe it? Till the end, I could not answer almost 90% of his questions. And he was very nice. And he said, oh, the Mashelkar dear, he always calls Mashelkar dear, Anil dear, etc. So he said, Mashelkar dear, I must compliment you on the binding. You know, it's a solid typing and binding and so on. I thought I'm going to fail, but they passed me. I want to tell you this in all humility, because this is very important. Then what happened was that I had some fascination for UK somehow or the other. I didn't want to go to US, England, you know, somehow or the other. I wanted to go there, and I had two offers, by the way. One was on I got an uh, associate lecturer's position in University of Manchester, which was ranked among the top 3 in Europe at that time. So it was a kind of a permanent position. The other one was a temporary one, just 1 year, Leverhulme Research Fellowship. In the first, I would have done exactly what I had done with Professor Sharma. In the second, I was going to do something which was called non-Newtonian fluid mechanics. Imagine that I did not know Newtonian fluid mechanics, the ordinary one, and this was a challenge of doing non-Newtonian, you know, which are very complex fluids, by the way, like polymer solutions, polymer bloods, polymer melts. Like our blood is non-Newtonian, they behave very differently, not like air and water. And the background is all tensorial and vectorial mathematics and so on and so forth, of which I knew nothing. Can you imagine, rather than taking that permanent position with a high salary and security, I went for this, because I remember that day when I walked out of that room where I could not answer a single question that Professor Kumar had. That was a change in my life. And then I built my own reputation. I built sort of non-Newtonian fluid mechanics school there, and so on and so forth. Then comes another turning point, by the way. I was doing very well. I had offers also from the US, and Imperial College in London, which is Cambridge and Imperial were the top at that time in Oxford. And then Dr. Nayaduma came, the Director General of CSIR in London. And I got at that time, you know, not like now the emails and all that. There used to be what is called as a telex. So I got a telex from Dr. B.D. Tirak, who was the director of NCL, and he said, go and meet Dr. Nayaduma. Now, Dr. Tirak had taught me, he was my guru, and you always listen to the guru, you know, don't ask why. So I just went and met him. And Dr. Nayaduma was then the Director General of CSIR. Like I later on became Director General of CSIR. I never thought that when I was meeting him, I will become myself Director General of CSIR, by the way. And at that time, he said, Mashelkar, when you become old, you will come back. But now in the time, I was barely 32, and establish a new school, in National Chemical Laboratory. And actually, those days, by the way, without interview, they used to make an offer. He made me an offer like that. And I came back on a princely salary of 2,100 rupees per month, by the way. Okay. So, because I don't think from here, I think from here. I said, my God, nation is calling me back. I must give back. And I must say, Vaishali has been a great life partner. When I phoned her up in the evening, she said, yes, if the nation is calling us, let's go. There comes the next story now. When I came here, you see the difference, how lucky you are and what the condition was then. You know, our journals used to come by sea mail. So it used to take 3 to 4 months. So what happened in the rest of the world, which you just Google and find out now, it used to take 4 months. So we were behind even before we started. Okay. As far as I was going to continue to do work in non-Newtonian fluid mechanics, but for that I needed a rheological equipment, and that would take 2 years to get, because there is no dollars, DGD clearance, not manufactured in India certificate. It would take 2 years. So what do I do? Do I just wait for that for 2 years? I said, nothing doing. What has God given me? This. Okay, I can use it. And I remember I was a consultant to Indian Organic Chemicals. We used to manufacture polyester fiber. And I found that they had no idea. Those days, basically, we used to import technologies. Okay. And if it is a German technology, Germans will tell us, plate like this, keep the pressure here, keep the temperature here, keep the wall there, and we'll just follow. And we would not know what was happening inside. And I remember telling them, and this is an important lesson in research, by the way, telling them that, look, I will sort of do modeling and simulation, and I will let you know what is happening inside that reactor. And I remember we simulated the entire chain, in technical words, there were transesterification, ester interchange, pre-polymerization, polycondensation, etc. Now that benefited them enormously because they knew what was exactly happening and they could change parameters without putting in any money and improve the productivity. So they benefited. I had my student Ravindranath who did his PhD on that. So he got his PhD. Okay. And most importantly for my career, I started research in 77. And one of the great prize that you can aspire for is Bhatnagar Prize, by the way, SS Bhatnagar Prize, before 45. That's the highest science prize you can get before 45. I got that for my 5 years of work. Now, here is that important lesson. The first is that you keep on knocking on the door of opportunities, they don't open. What do? You open your own doors. When the rheology door was not opening, what I did was that I opened my own door on modeling and simulation. I changed my path. All right. So that's a very important lesson. The second part is that, we always get confused between basic science and applied science. To me, there is nothing but science and its application. For example, the research that I did, would you call it basic or applied, or basic or industrial research? If you call it basic, how did the industry benefit from what we did? If you call it just industry, how did I get SS Bhatnagar Prize, which was meant for science? All right. So you must forget about this artificial distinction that you have between basic research and applied research. There is science and its application. Sometimes the application happens immediately. Sometimes it takes a long time. Like Raman effect was discovered in 30s. But Raman scanner that is used came so many years after that. So I think that we should just forget about. The next part, so I've given you 3 lessons so far as I walked on. Let me move to the 4th lesson. The 4th lesson was that I established a polymer science engineering school in NCL. That was the first school in India at that time, by the way. And we just had polymer chemistry, but we did not have polymer physics, polymer reaction engineering, polymer processing, and so on and so forth. Okay. And one of the first polymers that we created was a super absorbing polymer. I wish I had that polymer with me so that I could have demonstrated. So the demonstration would have been like this. I take a beaker, put water in it, and just take couple of grams of this polymer and put it in, and that 2 gram is able to absorb 200 gram of water. Can you just imagine? And I would have demonstrated to you tilting the beaker that nothing comes out basically. So it was like Agastya Muni, you remember how we sort of the entire sea. So that kind of a thing. And this was the big science which actually led to that. But at the same time, we say, what do you do with that polymer? And then we looked at India and Indian conditions, because such polymers were being used for baby diapers by the Western world. So if baby urinates, the urine doesn't go all over, it is absorbed. So that was their application. We looked at our problems. What was our problem? Our farmers. What was our problem? Droughts. What was our problem? Seeds are sown and then rains come and then they vanish for 2 weeks and everything goes fine. So we said, why don't we take those seeds and coat them with this polymer? Okay. So when the first rains come, this coating absorbs all the water and retains it. And even if the rains don't come, they keep on supplying it. We called it Jala Shakti. All right. And Indian Organic Chemicals in Khopoli actually started manufacturing that. Okay. And that business was later on taken over by others, etc. That's a different story. Now, here is once again, when you do some science, like the jail science that we did, we published papers and all that, etc. But the benefit of that science actually went to the farmers. And you can see again the matching of societal needs, industrial needs, and high science, somehow or the other. We unnecessarily do this bifurcation. In all my life, we have sort of not done. The next point I want to also mention is in terms of excellence and relevance. Excellence in science can be matched with relevance in science, like the 2 examples that I gave you from my own example, okay? But in terms of excellence, there are degrees of excellence, okay? So when you do research, you create new knowledge, isn't it? Now, that new knowledge, what difference does it make? Because if you see over centuries, a sea of knowledge has been created. The question that you have to ask yourself is that, am I going to put a bucket of knowledge and put it in that vast sea? Or am I going to create waves in that sea by creating new thoughts, breakthrough ideas, etc., etc.? Now, unfortunately, within India, we have not created those many waves, basically. We have created small hillocks, but not Everest. We require those peaks because many times you might think, no, why are we not getting Nobel Prizes? Why C.V. Raman is the only one who got Nobel Prize while doing work over here? It is because you get Nobel Prizes when you do things which are the ones which make science tend take a little left turn, a little right turn, and so on and so forth. So I think that is the most important part. And that is where what Nobel laureate Richard Feynman had said becomes important. And I will quote. He said, the difficulty with science is not with new ideas, but escaping the old ones. And certain amount of irreverence is essential for creative pursuit of science. Irreverence means challenging. Irreverence means questioning. And therefore, you must learn to question. Questioning, creativity, curiosity are fundamentals to doing great science. All right. So keep on asking the sort of questions, and that will mean changing our culture. Our major challenge is the rigid, unimaginative curricula, examination based on single answers, etc. You mug it up, reproduce, and you get marks. That won't do. For example, accepting for, let's say, science like Avogadro number, you can't change it. Avogadro number is Avogadro number. Newton's second law is Newton's second law. Okay, F equal to ma is equal to F equal to ma. No issue. But for other parts, you will always see that for a single problem, there are multiple solutions. And you must learn to do that. Any given problem. Never be a part of a problem. Always be a part of a solution, by the way. Okay. And that's what we do in National Innovation Foundation, in Srishti, everywhere. This is what we try to sort of promote. Solutions, and solution. Don't live with the problem, like in honeybee network and so on. So, normally I do an experiment once again. For some reason, I have to always take a glass of water for whatever it is. So I take a glass of water, and then normally I ask students, I have to take the water out. How will you take it out? First, young boy or girl says, sir, pour it out. Second says, break the glass. Third says, put a tissue paper in, capillary action. Fourth says, keep it in the sun, evaporation. Okay. Fifth, remember the story of the crow, those stones that were put and then the water came out and so on. And after 7 or 8, it stops. And I show them 41 ways of actually doing it. Now you also start thinking in terms of what could be the alternative ways. So your ability to do that becomes extremely important. The other important aspect of good science, I would say, which I also experienced, was many times accidents happen. But your ability to spot those accidents actually determines whether or not you will get a breakthrough. You cannot believe it. This is called serendipity, by the way. That means suddenly something that is unexpected that happens, and you say, "Oh my God, it must be a mistake," and just forget about it. No. If you look at the serendipity and Nobel Prize, Röntgen for X-rays in 1901, it was purely serendipitous. Frederick Bontling got Nobel Prize for insulin. That was completely serendipitous. Alexander Fleming's story, all of you must be knowing. Penicillin. The contamination of the mold that he got and how he discovered penicillin, etc. So similarly, there are even the polymerase chain reaction that all of you are aware of, Karen Mullick, was serendipity. Not only that, many things that we use in practice, like drug like aspirin or cisplatin or isoniazid, they all came from serendipity. So your ability to think, basically, and as they say always, eyes do not see what mind does not know. So that ability is extremely important in connecting the dots, for example, Now, in my own life, there have been serendipitous developments which have given breakthroughs in my life. For example, I remember once I was in Delhi and I saw Nature. Your ultimate dream is to publish a paper in Nature, and if it comes on the cover page, there's nothing like it. And we saw a paper, I saw a paper where I was working on the gels, as I told you, right? And there was a paper at the cover page of Nature which showed actually the patterns on the surface of a gel, and it appeared on the cover page. Tanaka from MIT had actually done it. So I came and showed it to my student, Badiger, who was also working. And he says, "Sir, this I had seen 2 years ago." I said, "My God, why didn't you report it? Because then we would have got paper in Nature." He said, "No, sir, I was afraid there was something strange. I didn't want to tell you." So I called all my students and I said, "Anything you see, anything unusual, you have to tell me." And that is where we got breakthrough, because when we were working on gels, for example, I was, of course, in DG of CSR. I used to come during the weekend and spend time in laboratory Saturday, Sunday. And one day, I remember Shiny Verghese, my student, reporting to me that I had a cylinder of gel, and I put it in a copper chloride solution, and the cylinder turned into a sphere. And not only a sphere, but a coconut-like structure, hollow structure. And I could reverse it to go to cylinder. That was a big breakthrough. It was called macroscopic self-organization. At that level, nobody had seen. And we deep dived into the theory, Ashish Lele, myself, and her. And those became breakthrough papers, because that was the first discovery of macroscopic self-organization. And then later on, as we went around, we found that only certain types of monomers, when copolymerized, only give that, not others. And that was called acrylyl 6-aminocaproic acid, A6-ACA. And that molecule had the kind of balance, of hydrophilicity and hydrophobicity. That only. You reduce one methyl group, it will not give. One extra group, it will not give. Just that balance. And that A6-ACA opened up completely new doors. You normally think that what MIT will do will copy. I'm sorry. This A6ACA by Robert Langer, who is considered as one of the greatest engineering scientists, actually used it to create sort of systems. It was used in stem cell adhesion. It was used for biomineralization. It was used all over. That A6ACA became so hot that lots of new doors opened up. You know, in science, they always say only those matter who say the first word in science or the last word in science. There is nothing like a last word in science, but first word in science which opens new doors. Now, creation of this A6ACA, we open the doors for the rest of the world to see. Otherwise, normally what happens? Bidnos Mueller will get a breakthrough on superconductivity, right? And then all of us will work on that. Somebody else will discover graphene. Now, for example, the story of graphene is a very interesting one. I want to tell you, poverty has nothing to do with breakthroughs. The Russian postdoc who shared the Nobel Prize, you know what was the simple experiment he did? He took a scotch tape, he put graphite on it, he put another scotch tape, and just did this, pulling up and again closing, pulling up and closing, until he got that the sort of monolayer of carbon, organized in a particular way. That is called graphene. Now tell me, how much does a scotch tape take? How much does a graphite take? Right. So resource poverty has nothing to do with it. Idea richness can overcome sort of poverty. So that is the point I'm trying to make. And I'm very happy to say that this work of mine, which is mine means my entire groups actually, Ashish Lele and everybody else, it was so much appreciated around the world that I got this Lenovo Science Prize of $1 lakh, which I've actually donated to my foundation, Anjani Mashelkar Foundation, basically. And this is considered, for developing world scientists, considered as a sort of a mini Nobel Prize. But where did it come from? It came from those accidental discoveries, which we actually basically took forward, and work done in NCL at a time when there was hardly anything at all. So that's what I keep on harping on. I would like to quote what Professor Flory, the Nobel laureate, had said about connecting the dots. He had said, significant inventions are not mere accidents. Many men floated in water before Archimedes. Apples fell from trees as long ago as Garden of Eden. Chance discovery involves both the phenomenon and the observation by an appropriate, intelligent observer. Because, as I said, eyes do not see what the mind does not know. So, how do you develop that ability? Our education system is we collect the dots. It is about connecting the dots, and particularly in areas which look completely dissimilar. So you can get breakthroughs if you develop this creativity and critical thinking. The last point I like to make is the following, that it is very important that our science, Indian science, must work for the poor. Who else will do it for us? And for that, I'll like to mention something. In my mother's name, Anjani Mashelkar, she always believed in, making science work for the poor. And the last note she had left before she passed away, she had said, she had collected all the money that I used to give her and left a note, use it for doing something good for the people. And I created Anjani Mashelkar Inclusive Innovation Award. Professor Anil Gupta has been the chairman of this award for the last 10 years. And we have always worked on ensuring that high technology can work for the poor. Because making high technology work for the rich is very easy. Making low technology work for the poor is very easy. But making high technology work for the poor is very difficult. And we do that. So I'll just give you one example in closing, which is symbolic. So one of the awards went to one Rahul Rastogi. Okay, what was his challenge? His father had a heart problem, and therefore he had to be taken to hospital to take his ECG, electrocardiogram, right? And you know how electrocardiogram is taken. You sleep, and then a nurse puts 12 leads on you, And then there is a paper readout. It takes half an hour and so on and so forth. He's an electronic genius. He said, why should I do that? Why can't I create ECG in my pocket? Looks ridiculous, isn't it? He did that. And it is here, by the way. This is ECG. Okay. How do you do that? You see these two things. You put sensors. You put your two thumbs for 15 seconds. This is another sensor here. This is your heart. You put 15, 15, 15 seconds. 15, 15, 15 seconds. And within 3 minutes, if you have downloaded an app called Sanket, the ECG goes to you. Cost per ECG, not 500 rupees, just 5 rupees. Can you just imagine? And what difference it can make? Supposing there is a woman, old woman in a village, and she has a heart pain at night. You don't have to put her in a bullock cart and take her there. Just do this. It is like using an advanced thermometer, and you can find this. So this is what we call as affordable excellence. Okay, Indian science is very special in terms of developing this affordable excellence. And I repeat that if we do science for the poor with excellence, like our Prime Minister says, make in India, but for the world, you can see this is getting exported now to the rest of the world. All right, but it is also helping the poor. So I hope that you will be able to create that big balance. So please make use of this great opportunity that you have. And thank you very much. I want to thank my friend, my brother, and my guru, Anil, for giving me this opportunity to interact with you. Thank you very much.
Thank you so much, sir. Thank you so much. We are very grateful. And I'm sure these participants of the BIIS will remain inspired for a long time. You have unsettled them, and this unsettled will create new chain reaction, which is what you have triggered. Thank you so much, sir. Thank you. Thank you, sir.
Anil, I have to join now Dr. Vijay Kelkar's IDF.
Right, sir.
India Development Fund. So I'll quit now, okay?
All right, sir. All right. Thank you, sir.